All right, so um, this is kind of like what the simulation is going to look like in a way, just that it's going to show you molecules that are bonded together like this and show you the products of how they look after. You really need to do the lab, okay? You really need to do what it tells you to do on there because it's going to help you tremendously whenever you have to balance equations for the quiz and the test, okay? All right, so just remember things like the atoms are conserved. You can see that there are 2 hydrogens here, and then look, there's 2 hydrogens here. And same with the chlorines. Mass is also conserved, meaning that you're going to have the same amount of weight on both sides. And then this is showing law of combining volumes. The gases at the same temperature and pressure contain the equal number of molecules. So just, you got 4 hydrogens here and you got 4 hydrogens here. Okay, so same temperature and pressure are going to have the same amount of molecules. And this is just saying that the units of measurement are used with equations. This gets us a little bit into moles. So basically what I want you to know from this is that 1 mole is 6 times 10 to the 23rd. That's a really big number, and it's known as the Avogadro's number. So if you think about this number and you think about a little tiny atom, it takes that many of them in order to equal that mass that it's given you on the bottom of the periodic, like on each element on the bottom of the periodic table. So it's giving you this example of carbon. If you look at carbon on the periodic table, it's like number 6, and it's 12 is the mass, and so that means that it's about 12 grams. Okay, if you had 6 times 10 to the 23rd atoms of carbon, then it would equal 12 grams. If you were to weigh 1 pound, remember, 1 pound is equal to 454 grams. Well, is a pound very heavy? No. And we're talking about 12 grams versus 454 grams. So still, even 12 grams is little tiny, very, very little. And it took this big number to even make 12 grams. So very, very, very small. And that's just kind of what you need to realize from chemistry. And then molar weights, gram atomic weights, are masses in grams that are equal to the atomic weight. So just showing you again that if you took Avogadro's number here, which is this huge amount, then it would equal whatever the mass in grams is on the atomic weight of the element. So, and then gram formula weight is the mass in grams equal to the formula weight. So this is just saying, like, let's say you didn't have just carbon. Let's say you had H2O. You could do Avogadro's number of a compound, so 6 times 10 to the 23rd H2O molecules, and it would equal whatever the mass is of that. So if you were to find the masses on the periodic table, so for hydrogen, for example, the mass of hydrogen is 1. We have to multiply that by 2 because of that one right there. So that's 2. If you look at the mass for oxygen, it's 16. So 2 plus 16 is 18. So the mass in grams is about 18 grams. If you had this 6 times 10 to the 23rd, 6.02 times 10 to the 23rd water molecules, then you would have 18 grams. And then this last one is saying gram molecular weight. The mass in grams is equal to the molecular weight. Okay, so this is just of a molecular substance. So you could say like O2 or something, Anyway, it's all going to be that it's going to equal whatever it adds up to if you had a mole of those, or Avogadro's number. And then last slide, this is kind of showing the same thing. This is saying that, you know, if you have a balanced equation, okay, that's why it's very important for things to be balanced. If you had a, you know, this hydrogen plus nitrogen yields this ammonia right here, then, and it's all balanced, then the molecular ratio of that would be that there's 3 molecules. That's this number right here that tells you that there's 3 molecules. There's no number right here, so that's basically a 1. Tells you that there's 1 molecule of N2, and then there's 2 molecules of this NH3. All right, so that's how you do the molecular ratio. The mole ratio is the exact same thing. It's just like there's 3 moles of H2, 1 mole of N2, and 2 moles of NH3. And then the mass ratio, okay, is that you've got 6 total grams of H2. Well, remember, this H2 is a molecule, okay? So how much is 1 hydrogen? What's the mass on the periodic table? It's that 1.0079 number. So it's basically 1. So, and there's 2 of them. So 1 times 2, that's that number. But then you got to multiply it by 3. So 2 times 3 is 6 grams. That's where this is coming in. And then if you look at nitrogen over here on the periodic table, nitrogen has a mass of 14. So if you take that times 2, then you end up with 28. And then, so you've got 6, right? So you've got 6 plus 28, which is equal to 34 grams. Well, so this mass has to equal the same mass that's on the product side. So just remember that your mass ratio has to be equal, okay? Whatever you have on the reactant side has to be what you have on the product side. Hey, that's it. So I'll put some homework out there, and I probably have to change a date on it, I'm sure. And then I'll also put the lab up on D2L, and you guys can get started on that stuff for the week. Alrighty. If I can get this to stop. Oh no.